There's this tension. I want u to be big because it will soak up as much of the problem as possible. But if I make my u too big, then my du is too complicated and it makes that part of the substitution too hard to work. This is a place where if I have my u as x squared and my du is there, can I make my u a little bit bigger? Well, in this case, I don't just have x squared on bottom. I have an x squared plus 3 on bottom. So I'd rather let u be x squared plus 3. If u is x squared plus 3, now what's du? Well, the derivative of x squared plus 3 is still 2x. I got a freebie. I was able to make my u bigger and soak up more of the problem without having to make the du more complicated. When you get a chance to do that, you should take it. X squared plus 3 is here a much better choice of u than just x squared, because it deals with more stuff. After the substitution, the plus 3 will be gone, not just the x squared. Anyway, let's try this out. A thing you can do is divide both sides by 2 here, and get x dx equals 1/2 du, and there's the x dx, and erase that and write a 1/2 du. A trick I learned from my calculus teacher, though, that I really like, is instead of doing the work on this side, do the work on this side. Say, I wish I had a 2 here, and fix that by also putting a 1/2. Very often in these problems, I like just put the constant I wish I had. Because it's a constant, it's allowed to move outside the integral. Only constants are allowed to just hop outside the integral like this. This was one of our first rules of, I guess I won't pull it up, but this is because a constant out front stays out front. I can pull a constant through the integral symbol. You can't do that with an x. And now it's the substitution passes much smoother. All of this stuff is now du. All of this stuff is now u. What have I not written down yet? There's the 1/2 out front and the 5 on top. Cool. It's sort of tradition when you have constants, just pull them outside the integral so you can see what you're looking at a little better. That 5 is a constant. I could have pulled it out front at the very start, but I didn't. I'll do it now. I can write this as 5/2 integral of 1 over u. Like, the goal is get the constants out of the way so you can see what you're really dealing with. I'm dealing with the integral of 1 over u. Is this problem easier? Yes, this is easier and cleaner than the original problem. Can I do it? Yeah, I know a function whose derivative is 1 over u. It's natural log u. So our answer is 5/2 natural log u. Oops, I forgot the plus c. Oops, I forgot the absolute values. Oops, I forgot your answer shouldn't be written with the letter u. The question was about x's. Your answer needs to be about x's. Translate this English answer back into French. How do I translate it? Well, here's my formula for u. It's 5/2 natural log absolute value x squared plus 3. There's our answer. When you do these, it is still a great idea to take the derivative and see if it's right. I'm trying to keep the derivative rules in a different place in my brain than I'm keeping the integration rules. And to do that, it helps me to do a version of both so that they're not bleeding onto each other. What's the derivative of this? 5/2 is a constant. Derivative of natural log something is 1 over that thing. The absolute value goes away when I do this. Times what's the derivative of the inside? The derivative of the inside is 2x. I'm supposed to end up with, the original problem was 5x over x squared plus 3. Is that what this is? There's the 5, there's the x, there's the over x squared plus 3, and the 2's cancel. Yes, this does equal 5x over x squared plus 3. The substitution worked. Hooray! Oh, and the derivative of plus c is 0, or plus 0. So that goes away too. Cool! Let's try another one. Oh, this one's rough. That's not that bad. The integral of natural log x over x. What's my u gonna be? This is a place where I want to leave silence and ask someone in the class to tell me what it is, but I don't have you guys here to tell me. The The only things I really see are x and natural log x, right? Those are the two obvious options. I already made a big deal about if you find yourself doing u equals x, that's the trap. Don't do that. That's just going to erase the problem and use the letter u instead of x won't do anything good. So I guess let's try u equals natural log x. There's often not a right choice. Often there are many things that work. Trying the same problem multiple ways is a helpful thing to do. I'm going to try u as natural log x. If u is natural log x, then what's du? It's derivative of that, 1 over x, dx. Is this a good... Oh, hey, there's a 1 over x right there. Awesome. This is working out perfectly. If I rewrite the original problem as log x times 1 over x dx, perfect. U are du, u are u. This is the integral of u du. I just need to be able to integrate u. Often, the letter u throws me off because all the original problems I did were about x's. If I make a note to myself, what's the integral of x dx? Wait, how do you... What? How do you do that? This is like, in this context, it's everybody brain farts. Remember, that's x to the 1. This is a power rule thing. Right, the integral of x is half x squared. That's the thing whose derivative is x. What's the integral of u? It's half u squared. du's gone, plus c is there. Don't put a box around this, because you gotta substitute in what was u. u was natural log x. There's our answer. I highly recommend checking. What's the derivative of half natural log x squared? It's half something squared. Derivative of something squared is 2 something. Leave the inside alone. That's ln x times the derivative of the inside is 1 over x. Derivative of the constant is 0. You're gone. Half and the 2 cancel. I got natural log x times 1 over x. That is natural log x over x. Check. It worked. Here's a gross one. Let's try the integral of x squared over x plus 1 dx. What do I want to try for my u? Picking the right u is the finesse part of the problem. There's a bunch of things in the homework that are about, here is a bad choice of u, force it to work. Sometimes you need to take a bad choice and force it through, and that's a good idea. Let's try u equals x squared. I'll show you what I mean by forcing something through here. If u is x squared, then what's du? du is 2x dx. How much of this can I substitute easily? Well, I get the integral of the thing on top is u. That x plus 1 I don't really know what to do with. That dx I don't really have a... I didn't have an extra x to stick with the dx. How do I cope with that? Well, I can cope with it by dividing both sides by 2x. That tells me that dx equals du over 2x. So I can get the dx to go away. It'll turn into a du... stupid stylus. The dx will turn into a du over 2x. I'm still not done because there's still x's there, but I at least got rid of the dx. How do I turn these x's away? I know if I see an x squared, I can turn that into a u. What do I do with another x? Well, don't forget, you know how to do stuff with equations. If someone hands you u equals x squared and wants to know what x is, you know how to solve that. X is the square root of u. Maybe a plus or minus is going on. Usually we don't deal with those plus or minuses, and they sort of take care of themselves. That says that in this substitution, anytime I see an x squared, I can replace it with a u. Anytime I see an x, I can replace it with a square root u. u over root u plus 1 times du over 2 root u. This would look more normal if the du was off the fraction. And also multiplying by fractions, you multiply the tops, multiply the bottom. So I end up with root u plus 1 times 2 root u du. Also, this 2 is a constant. I can pull him all the way outside of the fraction. That would be a 1/2 on the outside. U over root u plus 1 root u. Maybe you can think about pushing the square root in, and that'll get rid of one of the square roots, but it won't get rid of the other.